Welcome to today's Makino product introduction. My name is John Einberger. I'm the product line manager for horizontal machining centers here at Makino. I'm coming to you today from our North and South American headquarters in Mason, Ohio. One piece of housekeeping to take care of before we get into the content here today. If you see behind me circled on the screen that you're looking at for this broadcast, there's a chat and a Q&A header. Either of those can be used to input questions that I'll answer on the backside of today's product introduction. So any questions that come up, please go ahead and use those functions to get the questions in, and we'll handle them on a question-by-question basis on the backside of this introduction. So let me start off with a question. Do you machine or do you want to machine parts that fit this profile? Automotive type components, think about transmission cases or EV motor housings, cylinder heads, the periphery features on an engine block, something like an oil pump housing, or auto structural components where maybe there's a whole variety of features at compound angles that you need to have access to. Are the parts near net shape, and are they non-ferrous? Pretty long list, but a lot of components out in the machining landscape fit into that category. Other things to think about, are the parts a representative of stable production, something that once you set it up, you're going to run it for a long period of time? And would they really fall into that category of medium to high volume production? If so, the J6 family of machining centers probably will be of interest to you. Let me start out with the kinematics of the machine. The J series are all stacked axis style machines, meaning that the linear axes, X moving left to right, Y up and down, Z in and out, all happen away from the workpiece. For those linear axis movements, the workpiece does not move. That allows the machine to really present itself well from an automation perspective, and we'll get into that detail here in a little bit. From a workpiece movement standpoint, it's only going to encompass the rotary movement of the workpiece. From a size perspective, the J6 family, relative to maybe known quantities in the Makino landscape, the A40, the A51NX, or the big brother A61NX, falls bigger on the X-axis stroke, even bigger than the A61NX, and right in that sweet spot of 560Y, 500 millimeters of Z. Again, really tailored towards those automotive prismatic part type layouts that you're going to see in the manufacturing of those components. We have multiple configurations of the J6 to meet specific customer needs. The first kinematic arrangement features an A-axis, so the rotary axis revolving around X. The converse of that is a B-axis configuration with the rotary axis revolving around Y. And for those auto structural components in particular, a combination of a B-axis over an A-axis for a 5-axis really good open feature access to the components and the features that would be on those auto structural type parts. The J6 family features true 3-point leveling, meaning that it's a reduction of the cost and the complexity of the foundation that you need to prepare to hold the machines. It simplifies the installation process for the machines coming into your factory. It's easy for you down the road if your configuration changes to relocate those machining centers. And probably the biggest takeaway, there's no periodic releveling maintenance required, since the alignment of the machine itself of one element of the machine to another element of the machine is built into that machine assembly, not reliant on the position of those 3 leveling points. Looking at the rotary axes in a little bit more detail, all of these are direct drive axis, regardless of configuration of the machine. So no gear train inside of the rotary axes, very simple from a maintenance standpoint, high reliability, and very fast movement. All the rotary axes move in 0.001 degree increments. All are fitted with high capacity brakes. So basically position that axis, clamp the brake, go about machining, unclamp, so on and so forth. And of note, these rotary axes are not of the contour machining type. They're of the position the axis, do the machining, position the axis, do more machining, what we would call point and shoot machining style processes can be run on the J6 family of machines. And each of these are equipped with a 12-port rotary union to allow a combination of hydraulics and pneumatics to go from your hydraulic supply unit to the work holding fixture. From an indexing perspective, all of them, again, being direct drive, are very fast. All of the specs that I'm going to note here are at maximum payload in kilograms. And so the 180-degree index time for the B-axis variant, 1.7 seconds, inclusive of all that movement, clamp and unclamp. The A-axis, 2.3 seconds for that 180-degree move. And the combined B over A-axis, 2 seconds on the B, 1.8 seconds on the A. Again, very fast machines from the standpoint of getting that position to allow the machining of the features that you're after. From a spindle perspective, 2 spindles are available on the machine. Regardless, they're both ram-style spindles. So remember earlier I talked about this being a stacked axis style machine. The movement of the Z-axis, instead of the workpiece coming towards the spindle extends out towards the workpiece. The 16,000 RPM high acceleration spindle is standard, but we also have an option for a 12,000 RPM enhanced output spindle. If you're familiar at all with the Makino A40, that also has a 12,000 RPM spindle. While they're not the same spindle between the two machines, they're very similar from an output perspective, both in power and torque. Both of these are unique to the J6, and they're offered in our market in the HSK A63 interface. From a global perspective, there is an alternative for HSK 50 for these same spindles, but we've elected to use the HSK 63 since it offers the same performance as the 50, but in a bigger, more robust connection. From an output perspective, these are all detailed in the detailed spec sheet available on the machine through your Makino sales representative. But just from an overview perspective, comparison, if you will, of the 16,000 RPM relative to the 12,000 RPM enhanced output. The tool magazine on the machine is an overhead drum style, kind of featured here. What it does by mounting that up over the top of the machine is it keeps the footprint of the machine very narrow, and it also allows in an automated cell machines to be placed very close to each other, minimizing that pitch distance from machine to machine to machine in the overall floor consumption that's used for a given cell. So a view inside of that drum style, 30 tools is a standard configuration with an option for 40. Standard on the machine, also a contact style broken tool sensor. And the tools are loaded in the standard configuration into the magazine through the spindle. Very typical for a stacked axis style machine such as the J6. We do have the option for a tool load station. And if a customer were to buy the option for the tool load station, also available on the machine, the ability to use the bailiff chips for tool ID to get that data directly from that chip into the tool registers on the control side. Quick video from the inside of the machine showing what that tool change looks like. That's inside of the tool magazine looking down. You can see the contact style broken tool sensor coming into play, checking each of those tools for integrity before the next tool is allowed to enter into the cut. Same activity, but from the machining chamber side. Spindle goes up, does the tool change, back down into the workpiece, up for a tool change, back down to the workpiece. One thing to note, if you saw this artifact that I circled in red, that's an optional tool runout sensor. Where a customer might consider using that is if you have very tight diameter control required. Think again about that cylinder head example. Typically the valve features extremely tight runout is required between valve seat and valve guide. That runout sensor is ultra precise, and it's looking at every tool that comes into that spindle to make sure that it conforms with the desired runout specification. From a coolant perspective, multiple systems standard on the machine, the machining area, what you would expect from the standpoint of overhead shower, periphery coolant, things of that nature. Spindle nozzle coolant standard. And then tool taper wash is also standard on the machine, keeping the possibility of getting chips and debris in between that tool face and the spindle face down to a minimum. Video of what that system looks like during a tool change. You can see that ultra clean coolant being sprayed on that spindle to tool interface during the tool change process. External fixture coolant also standard on the machine. This is a view from the spindle towards the workpiece. A whole array of nozzles on the left, a whole array of nozzles on the right. Again, being able to be turned on to spray that part down with coolant, typically prior to and during part unload reload processes. The machine is designed to be very clean on the inside with very vertical walls, enabling chip flow down into the center trough conveyor. That, coupled with the standard coolant systems, really aids that chip flow out of the machine. I'm going to run this video here in a second just to point out this is an A-axis configured machine, but for clarity purposes, with the work holding fixture being taken out of the machine, just to again show that coolant flow down in. One thing to notice about the rotary axes, the A-axis platens both on the driven side and on the support side, very far out to the periphery of the machine. Not a lot of area for that driven unit to be catching chips. Further with the coolant system, rear-mounted lift-up chip conveyor and tank. Cyclonic filtration is standard. I mentioned a moment ago the super clean side of the coolant that services the through spindle coolant as well as the tool taper wash. That cyclonic takes the coolant that comes past the standard drum filter and does an ultra-fine filtration of it into a super clean tank that services those two systems. One thing to note, from a service standpoint, the coolant system does not need to be removed from the machine or pulled back in order to do sumping style maintenance, in order to do a pump out, a clean out, and a refill that needs to happen on a recurrent basis. You do not need to remove that coolant tank from the machine. The machine is designed around very high productivity, fast acceleration across the board. 75 meters per minute is the traverse speed, all the linear axes. High acceleration on X, Y, and Z, and also on the spindle. That 16,000 RPM high acceleration spindle, half of a second to get from 0 up to 16,000 RPM, half of a second to get from 16,000 back down to 0. So very, very fast acceleration of that unit. The control on the machine is the Makino Professional L or Pro L. It's a FANUC 32i based control, but ladder based. So easy to integrate in peripherals, easy to see the interaction between ancillary items that might be in that cell that are feeding the machine and the machine tool itself. Very production focused. One of the qualifiers that I had up front, does this machine have the intention of being used for stable production? The control is really designed to be set up and then just run on a daily basis. From a standard features perspective, a very large array of standard features on the control, but with the normal FANUC options on top of that available for customization. On the front of the machine with the fixture control system option, it comes with a standard HMI. Very easy to use from the standpoint of the manual operation of a fixture, but also the operation of that panel can be integrated into a cell control system for that machine in a robot system. Speaking of that, the machine is very automation friendly, can be used in conjunction with overhead gantry, robotics feeding either through the top door or through the front door, or in the more traditional on the Japanese manufacturing setting side, the walk line. And from a maintenance standpoint, very easy maintenance access to the machine. That was one of the major design hallmarks of that entire J6 family. Multiple access doors around the perimeter of the machine. Easy access from a maintenance standpoint to the X-axis motor. The main control panel on a swing so that you can position it to be accessed when the machine is in automatic mode with automation running on the front side of it, or swung around to the front for setup purposes. Centralized location of the valves that handle the flow to the work holding fixture. And again, pointing out where that secondary cyclonic filter is, with a sludge box system used to take the ultrafines out of that coolant system. Makino has more than 10 years of experience implementing cyclonic filtration units into machines. One of the lessons learned during that period of time is we really need to have a secondary collection spot for the sludge that comes out with the cyclonic to keep us from being in the situation of filtering out the sludge, but then accidentally reintroducing it back into the coolant. That's why we use a sludge box design on all the Makino product that features cyclonic. Also, grouping of the coolant and conveyor-related electronics in one centralized location. Switching to the other side of the machine, again, still from a maintenance access perspective, easy access to the backside of the X and the Y-axis covers. One location to group all the coolant control solenoids. Similar for the pneumatic and the lubrication devices for the machine, all grouped in one location. And that same comment about the ability to service that coolant tank without removing it from the machine. And the location of that super clean tank that services the through fixture coolant as well as that tool taper wash. Makino offers a full array of both metal cutting turnkey and automated system services to work with you on implementing a J6 style machine into your automotive production line. And with that, I'm going to close out, say thank you for joining us today, and open up the floor to questions.
Good afternoon. John is on the road this week, and so I am filling in for him. My name is David Ward. I head up the product management team here at Makino. We do have a couple of questions that have come in on the J6 product. I'll kind of go through those here. First one that I see that's come in is a question about the size of the machine. The question was whether there was any larger versions of the J6 machine. There are not larger sizes of the J6, but the J6 is actually part of a family of machines. There is a J5 machine that does offer larger sizes. In the case of the J6, we've got an X stroke of 750 millimeters. With the J5, it's available in either 800, 1100, or 1500 millimeters of X travel. So ability to handle those larger components. That machine also has a spindle that is designed or has spindle selections to give us the ability to machine ferrous type material, so irons or steels as well, whereas the J6 does not. Next two questions kind of relate to the part side. One question was, why is there no pallet changer? These machines are really designed for free part transfer. So there is a single fixture that would be on the machine, and then they're designed for high volume. So we're going to have automation, or there would be some sort of automation to transfer the parts from one machine to the next. So there are a lot of the high volume manufacturers like this kind of approach. It helps them reduce their costs. They only have one fixture instead of two. Simplifies the machine, eliminating the pallet changer. It helps take some costs out. And as well, they get better traceability. If there's any question of where did a particular part come from, you don't have to wonder whether it came from fixture one or fixture two. And then the last question that I see so far is what kind of hydraulics can the machine support for the fixture? These machines, the hydraulics for the fixture are going to come up through the table. So there are up to 12 ports that would come through the table, and those 12 ports can be configured for either fixture hydraulics up to 3,000 psi, pneumatics for air seat detect. So if you want to confirm that the part is sitting on the locators, and then we can also run coolant up through those ports. Where you would use coolant would be if you're wanting to clean off some of the locators. So after the automation removes the part from the fixture, the ability to turn on those coolant lines and clean the locators off before the next part is loaded on top of the fixture. So that appears to be all the questions that we've got so far. If you have other detailed questions on the J6 or any of the other Makino products, I'd encourage you to reach out to your Makino representative, and we can set up a one-on-one experience center call with you to talk about your specific application. So thank you very much for your time. Have a good day.